In the last lesson, bits became numbers. Now the same bits become logic inputs. A logic gate is a tiny Boolean function. It receives one or more input bits, applies a rule, and produces one output bit. We usually name the inputs A, B, and sometimes C. The output is often called Y. The important shift is this: a gate does not care where the bit came from. It only sees 0 or 1, then follows its rule every time. That repeatable rule is what lets us build reliable digital circuits from simple parts. Start with the three basic ideas. NOT flips one bit. 0 becomes 1 and 1 becomes 0. AND is strict. Its output is 1 only when all inputs are 1. OR is permissive. Its output is 1 when at least one input is 1. These three rules already feel like small sentences. Not this, this and that, this or that. Digital design turns those sentences into hardware. A truth table is the contract for a gate or a whole combinational block. It lists every possible input combination and the output that must happen for each one. With two inputs, there are 4 rows: 0, 0, 0, 1, 1, 0, and 1, 1. For AND, only the last row gives 1. For OR, every row except 0, 0 gives 1. When a diagram feels confusing, the truth table is the clean way to remove all ambiguity. Now let us solve a small circuit. The expression is y equals A and B or not C. First compute A and B, then compute not C. Finally, OR those two intermediate results together. If C is 0, not C is 1, so the final output is automatically 1. If C is 1, not C is 0, and the output depends on A and B. That means only the row A equals 1, B equals 1, C equals 1 still produces 1 through the AND path. The table makes the behavior visible. 2 more gates appear constantly. NAND means not after AND. It is 0 only when all inputs are 1. NOR means not after OR. It is 1 only when all inputs are 0. XOR is the difference detector. With 2 inputs, it outputs 1 when the inputs are different. NAND and NOR are especially powerful because each one can build every other Boolean function. That idea will matter later when we design real circuits efficiently. Here is the mental model. Gates are Boolean functions. Truth tables are their exact contracts. Small gates combine into larger combinational blocks, and those blocks still have truth tables. In the next lesson, we will stop drawing every row by hand and begin using Boolean algebra, including De Morgan's laws, to rewrite logic without changing its behavior.